All right. So 8.4 is when we start doing probability. So finding the chance of something happening. That all those ideas are just probability questions. But the first thing we need to know is figure out if this is a proper distribution or probability model. The first thing when you have a model, they need to add to 100% or a whole number of 1. If I add 0.4, 0.3, 0.1, 0.4, is that 1 exactly? If it's not exactly 1, then it is not a distribution, a probability distribution, also called probability model. That's 0.8, 0.9, that's 1.2, right? So this is not a probability model. Also, you cannot have negative probabilities. It doesn't make any sense, right?
So it would be B.
Yeah. Yeah, this is the only one that makes sense because there's no way you can't say I have a -% chance of rain or whatever. That's doesn't make sense. So yeah, it looks like this will be 100%. So this is the only one that is a probability model. Okay. The idea, so the formula that you need, right? So the probability of an event, let me change to a smaller, thinner line here. So kind of big. So this notation right here, P of A means the probability of event A happening. That will always be equal to the number of ways A can happen over the number of total possibilities in the sample space S. So in this case, A is a coin toss or flip. Well, actually, they're not asking anything specific. They just want me to create the model. So we'll use this in a minute. But in general, A is event. That's the ugliest N ever. S is the sample space. So we're going to need that for part example 3. So it's continued. But first, let's create the probability model, just like we had a period that was given to us, right? If we scroll up, we have outcome and probability. Make sure it looks exactly the same. Yeah, outcome here, right? Here I'm just going to call it probability of whatever event we're talking about and keep it shorter. So the first event is getting heads. Probability of getting tails. So obviously when you flip a coin, 50%, right? 1/2. So it'll be 0.5. And the other event is 0.5. So obviously this is a true distribution because it adds up to 1. And so that's all they want. But this is all the big picture ideas on the side here. So in example 3, they say, suppose now the coin from the last example is not fair in that the heads is 4 times more likely to occur than tails. Okay. So if this coin is this coin is tossed twice, construct a probability model. Okay, so heads is 4 times more likely to occur than tails. So how would we write that?
100, 0.
Well, it has to have, tails has to have a chance to come up. Can't be 0. So let's think about it. I'm not sure either. Let's think about this. So those will be the same thing, the outcome. Whatever. P of A, probability of heads and tails. Those are 2 different events. This is kind of like A1 and A2, I guess. So I'm just going to put H because it's hard to write with the mouse. All right. So heads is 4 times more likely. So I'm thinking if this is 0.8, this would have to be 0.2, right? Because 4 times 0.2 would be 0.8, and then they add up to 100.
I was thinking 90, 10. I don't know.
Yeah, I was thinking like maybe 0.75, but I'm like, okay. But I needed to add up to 100%. So this is the only one I could come up with. The 0.2, 0.8. So it's a weighted coin or something weird. Well, that's all they mean by probability, also called probability distribution. Okay. So example 4, let's do that on paper. To calculate the probability that a family with 3 children will have all boys or all girls. So let's assume the 3 kids already exist so that we can avoid things like death / twins, triplets, that type of stuff. So there's a family out there somewhere that you have 3 kids and they want you to guess what is the probability that they are this or that. Okay. So let me just write that down over here. It's 8.4, right? Yeah. Probability. So this is a fun section, especially when we start thinking about gambling. Example 4. Calculate the probability that a family with 3 children will have all boys or girls. Then the answer is something specific. What is the probability of having 2 girls and a boy? All right, let's switch over. All right, so calculate the probability that a family of three children. So as we talked about last time with the counting principle, right? So we assume that every single time you have an option of boy or girl, that means for first kid you have 2 options, second 2 options, third. Now, if you know the number of options, the fundamental counting principle says you multiply together. So the total possible outcomes in this scenario will be, so the number of elements in S, meaning every possible outcome. So N of S means the number in that set, the total elements. It's going to be 2 times 2 times 2. So first kid, for second, third kid. 8 outcomes. Okay. Now, we can list them all and say, you know what, S would be equal to, we can go the long way and figure it out, right? You could have all girls. You could have a girl, girl, and then a boy. Yeah, you can have a boy, boy, girl. Then we gotta have 8. That's what the theorem says. Boy, girl, boy. You could have nothing but boys, right? 1, 2, 3, 4, 5. So 3 more. Girl, boy, girl. Girl, boy, boy, right? And so that 1, 2, 3, 4, 5, 6, 7. So 1 more. What am I missing? Boy, girl, girl, right? Yeah, there it is. This is every possible outcome. Okay. So order is important because, you know, it's a different situation if you have a girl first versus a boy first. Okay, so we're going to treat those as 2 different events. Like, for example, these 2 have 2 boys and a girl, right? So depending on how you think about it, this could be the same event if you don't care what was first or what order it was important. If you only wanted specifically this situation, then maybe you wouldn't count it, but we're going to assume order matters when you're having kids because it's a different situation. Okay, so now the question says, so the event A is the event of having 2 girls and 1 boy. So the probability of that happening, we're going to have to first figure out how many ways this can happen. What is the number of elements in A? What is inside A would probably help us. So anything that has 2 girls and a boy will be put in here. So this will be a subset of S. So we got 2 girls, boy, right? So there's that one right there. Girl, boy, girl. What else? Boy, girl, girl, right? Did I miss any? I think that's it. So the number of elements in A is equal to 3. Because you can count them yourself. Okay, so then we use that formula we wrote down earlier. So whenever they ask for the probability of an event, probability of A, the event of having 2 girls and 1 boy, that's going to be equal to the number of elements in A divided by the number of elements in S, which will be 3 out of 8. So as a percentage, what is the chances of that happening? Yeah, so 0.375, which is 37.5% chance. That is the probability of this particular event happening. Does that make sense? Right? You just find out how many ways it can happen, divide it by the total ways. That's all you're gonna do. So if they say, what's the chances of heads? You'd say, in a coin toss, 1 out of 2. Right? There's only one way to get heads out of 2 outcomes. So that's going to be the same thing over and over again. The complexity comes in when we're trying to figure out how many ways things can happen. But in essence, that's the theory, fundamental principle. Let's look at example 5. We're rolling dice here, or maybe a single die. Let's see. Suppose a fair die is rolled. Let E be the event where you rolled an even number, and let F be the event rolled. F be the event that you rolled a 5 or a 6.
So that'd be 2, 5, and 2, 5.
Yeah, even number.
I played one D&D, so I'm like, all right.
Me too, man.
Oh, wait, it'd be
Just think
a
about
fair
this.
die.
An even number, so it'd be 50% chance of a even number for.
Yeah, actually, let's write down the events. So for E, for a 6, it's assumed, did they say 6-sided?
They said a fair die, but then it said rolled a 5 or a 6.
So let's assume it's a 6-sided die, not a D20. It didn't specify, so that's their fault. So even numbers, that set would contain 2, 4, 6, right? Okay. Event F says you rolled a 5 or a 6. So now they're asking, write the event E and F, meaning E. So when you hear that word and, they mean intersection. So what do these two sets have in common?
6. Number 6.
Yeah, so intersection means what they have in common, which is going to be 6. So the number of elements inside the intersection. How many elements are in there?
6.
It's a single element, right? So it contains the number 6, so 1. 1 element. Okay. Now part B says E or F, so that means union. So that's where you combine the set. So E union F, you combine all the elements in both sets into one set, but you do not repeat elements. So you'd have 2, 4, 5, 6. Right? 2, 4, 5, 6. Yep. So the number of elements in that new set, the n, that's all that n means. It's just count how much stuff is in there. So 1, 2, 3, 4. Okay. So knowing how much what's inside the elements or how much is inside the elements will help us compute probabilities. So what's the probability of E happening? In other words, what is the probability of getting an even number when you roll a 6-sided die?
50%.
It's going to be 50% because we got 3 elements in E out of 6 total possibilities, right? Which is 1/2. No big deal, right? Probability of F. What is the probability of getting a 5 or a 6?
That would be 1/3.
Yeah, you're right. So that would be 2 possibilities out of the total. So that will be 1 out of 3. Okay. Now, what is the probability of having an even number and so probability of E and F, right? So we have that would only leave this option here. So there's only 1 out of 6, right? Okay. Probability of the union. What's the probability that I get an even or a 5 or a 6? So just count them.
That would be
4 out of the total possibilities. So that will be 2/3, right? Which is a roughly 66% chance. And this is about 33 and change. Anyway, that makes sense. I know the actual answer might be simple to find, but the theory makes sense because it's going to get more complicated. Excuse me. All right then. Let's move on to something else. All right, so suppose 2 6-sided dice are rolled. Find the probability that the sum of the numbers on the dice is 10. Okay, let's do this one on paper. It's example 6. Suppose 2 6-sided die are rolled. Find the probability that the sum on the dice is 10. Okay, so let me switch back here. So let's call the event A rolling a sum of 10. Okay. So when you roll a single 6-sided die, how many outcomes do you get?
you can get up to 6 outcomes.
So if you roll 2 of them,
12.
The fundamental principle says you multiply the 6 times the 6. So you're
So
gonna,
36.
Mhm.
Oh, okay.
it's going to be 36 different outcomes. So for example, with the babies, right? It was two each time. So 2 times 2 times 2. You flip a coin to be the same. Be heads, tails, heads, tails, heads, tails. You would have 8. So 6-sided die. For roll 2 of them, there'll be 6 times 6. So the number of total outcomes is 6 times 6. I'm not gonna write all 36 down, because that's annoying, but this is the number that we're gonna need. But we will write down all the possible outcomes inside the A. I think my pen's down here. Switch. So all the total possibilities inside the A. So we can get what? I'm gonna write them as ordered pairs. 6, 4 will get me a 10. 4, 6 will get me another 10. Is there any other ways to get 10?
5, 5.
5, 5, is that it?
There's
Looks like it, right? So there's only 3 ways to get a 10. We consider 6, 4 and 4, 6 to be 2 different events because technically each die can be something different. So it does increase the probability. 5, 5 and 5, 5 is really one outcome. You can't, it's not different, even though it feels different. Probability of A will be equal to the number of elements inside the A divided by the total ways you can roll a pair of dice. So that'll be 3 out of 36. Is that going to reduce? Does it reduce?
it goes to just 0.083 carry.
What is it as a fraction? 1 out of 12, right?
1 out of 12.
And what was the decimal?
And for the it's 0.083.
Bunch of 3s or just random?
Just bunch of 3s.
Okay. Oh, that little line means that repeated 3s for forever. So that's about 8.3% chance. 1, 2. So 3 out of 36 is about 8.3%. Then you're going to roll a 10. Yep. Alrighty. Okay, let's look at another one here. give birth to a child who is healthy. Let's get that. All right. One moment.